Okay, we're going to find the limit as x approaches 0 from the right of x to the x. Now obviously if we just plug in 0, this is going to be 0 to the 0, which is indeterminate. We don't know what that's going to be. So we're going to have to do a little more work. Now when I look at this, think x to the x. We can't really just apply L'Hopital's rule to this because there's nothing on the top and the bottom to differentiate. So we're going to have to do something else. But what I'm thinking is, if we take the natural log of x to the x, that would let us bring this power of x to the front. Then we'd have x times natural log of x, and in that case we would know how to take the limit. So I'm going to call this entire limit L, and what we can do is see what happens if we take the natural log on both sides. So the natural log of L is equal to the natural log of this whole limit. But because the natural log is a continuous function when x is greater than 0, we can actually bring the natural log to the inside of the limit, because we know a positive number to a positive number, because x is approaching 0 from the right, that's going to be positive. And when we have the natural log of a positive number, that's a continuous function. So this is going to be the limit as x approaches 0 from the right of the natural log of x to the x. And now we know we can take this power of x, bring it to the front just like this. So you have the limit of x natural log of x. And now you can check the description. I've made a video on this limit, x to the a natural log of x, as long as a is greater than 0. And in this case, a is just 1 because we have x to the first power. This limit is going to be equal to 0. So we have that the natural log of L is 0. And in order to get back L, all we have to do is take e to the power of both sides. So e to the natural log of L is just L, and e to the 0 is 1. So we know the limit as x approaches 0 from the right of x to the x is equal to 1.